Hello, everybody. My name is Jeff Cayax, and this is my partner.
Hi everyone, my name is Satya Mehta.
And our research is the synthesis and characterization of polymerizable catanioic surfactants.
Okay. So the purpose of the research is to synthesize this surfactant you see on the bottom, and this is done using various organic reactions and organic laboratory techniques. Uh, Once we get this surfactant, it is then polymerized using the UV polymerization, and afterwards it'll be tested for its various properties. So the synthesis of this final product is done in multiple steps, and throughout every single one of the steps, we use standard organic chemistry synthesis techniques and analysis techniques to verify that we are at the step we need to be. So some of these analysis techniques are TLC, NMR, IR, and melting point. So generally, each step or synthesis of each part of the final product is done in the following general ways. So first, we prepare a write-up of the reaction, which includes any theories and what reactants we will need and any stoichiometry that we may need to do before we set up the actual reaction. And then it's the physical setting up of the reaction. And after a couple days, we extract it and test the product for its purity.
The first step of this research is to synthesize 112-dibromododecane from a starting compound 112-dodecane-diol. This will be an SN2 reaction in which 2-bromine replaces both of the alcohol groups in the 112-dodecane-diol to make 112-dibromododecane. The reaction will be set up by mixing 112-dodecane-diol with excess HBr in a rum bottom flask and a reflux apparatus. The reaction will then be ran for approximately 48 hours with high heat, in which the compounds will be extracted and tested for purity. In this particular reaction, two products are made, and the extraction of these two products will be done using a liquid-liquid extraction. And the solution, in the water solution that the reaction was ran, there will be unreacted HBr, both of the products. And so by putting the aqueous layer in the separatory funnel and adding hexane, the desired product and the other undesired product, the monobraiding product, will be transferred from the aqueous layer to the organic layer. In hexane, then, only 112-dibromododecane and 12-bromododecane diol will remain. Afterwards, the hexane solution will be put in a rotary evaporator and hexane will be evaporated due to its volatility.
So again, more often than not, the mixture of these products is just unavoidable. And for this reason, it's important that we find an efficient method to separate the compound. So the known method that was previously used in the research is column chromatography, right over here, using silica gel and pentene as an eluent. So basically, this leaves the bromo alcohol behind and collects all of the dibromo. However, this is generally more difficult to set up, and we wanted to avoid it if we could. So after some research and getting suggestions from Dr. Joe's, we decided to try recrystallization. After multiple trials and error, we were able to recrystallize the dibromo by solvating the bromo alcohol and dibromo, so our mixture, into methanol and heating it up. So once we heat it up, everything dissolves, and then upon cooling it, dibromo precipitates first because of its nonpolar nature. We then vacuum filtered the solid using the separate using or we vacuum filtered the solid successfully, separating the two products. So here's a little clip of the time lapse of how it precipitated. So once the desired product is separated, purification tests are performed to evaluate the degree of purity. So thin layer chromatography is one of the tests conducted after each reaction, and depending on certain attributes of the silica plate after sample processing, it can tell us whether we have one or two products. So over here on the left, when we put it under the UV light, we see that there are 3 black dots. And we should only see one, like you see on the right. It's slightly faint, but there is a black dot and only one black dot. So that's how we want it to look after we extract it. And so once we recrystallize the product, as you can see, we only see one dot on the silica gel plate. And then another test that you can also perform is infrared and HNMR spectroscopies, and these are generally better, and you do them after the TLC, and they give you better results. They let you determine the chemical compound and everything afterwards as well. So another test that we can also do is the melting point analysis. We can take the known product and then our extracted product and test both of their melting points, and if they're the same, then we have a pure compound.
This is where we are at our current point of the research. And for the future goals of this research and future duties, we will have to get our 112 dibromododecaine, and we will react it with trimethylamine to synthesize 12 bromo NNN trimethyldodecane 1 aminium. After extraction and testing for its purity, we will then react this compound with sodium acrylate for an esterification reaction. And this will give us the portion of our product that is now able for polymerization. And once the cationic surfactant is completely made, its physical properties will be tested. Some of these tests will involve spherulites, polymer organization, and thermodynamic data. Thank you for your time. And do you have any questions for us?